Hello, my name is Manik Maharjan, and in this video I will be talking about traffic flow theory. In the most basic sense, traffic flow is a theory based on flow of vehicles on the lane, its connections with other vehicles, pedestrians, and signals present on the road. There are numerous factors that affect traffic flow, such as the site. Traffic flow differs from site to site, and each one is geographically and demographically different, requiring different and changing geometric layouts. The amount of heavy vehicles on the road. A road with higher volume of heavy vehicles will affect the flow of other vehicles as they tend to speed up to pass the bigger vehicles, and is often time there is a separate speed limit for such large vehicles. Hours of the day. There will be higher traffic flow during peak hours, such as between 7 a.m. to 9 a.m. and 3 p.m. to 6 p.m. when people are commuting and to and back from work. The flow will be higher than during midday and early afternoon, where people are more likely to be at work, and significantly higher than the late evening when people are highly likely to be at their homes. The days of the week. The weekdays between Mondays and Fridays will see higher rate of traffic flow compared to the weekends, as Monday and Friday are the common working days for most people. Months of the year. We can expect to see higher traffic flows during summertime, especially on the highways when people tend to go out and travel or go on a road trip with friends and family, taking holidays and break from work and school. All these are some basic factors that affect traffic flow. When a roadway is designed, engineers make predictions and calculations about how it is going to be used by the drivers and pedestrians in different conditions. The plans are based on factors such as these. Given the advancement in the field and the skills of the engineers, these predictions, calculations, and plans are often highly accurate. However, there is still a chance of uncertainties being present in the real-life conditions which affect the traffic flow. Hence, a traffic flow study based on traffic flow theory helps engineers analyze and compare theoretical data with the actual data. They can use the results to improve any problems with the existing roadways. Now, naturally, most people would think adding more lanes will reduce traffic congestions and improve traffic flow. However, more lanes does not necessarily equal smooth traffic flow. In most cases, more lanes mean more volume on the road, as new drivers are highly likely to take the new route to their destination, hoping they'd reach it faster. This increases the traffic volume, hindering traffic flow. And good example would be the Embarcadero Freeway in San Francisco. After the 1989 Loma Prieta earthquake, San Francisco removed the freeway that carried more than 100,000 vehicles every day. Instead of retrofitting the freeway and repairing it, the authorities decided to remove the freeway completely. However, even after the removal, the commuting remained the same. Most people found a new route or resorted to public transportation. This is a great example of changing traffic flow due to change in multiple factors. So the flow increased in the new routes which people discovered after the freeway no longer existed, whereas the flow decreased in the roadway where the freeway used to exist. Now let's talk about methods of measuring traffic flow. The flow is measured by the number of vehicles passing a particular station during a given interval of time. They can range from 24 hours per day, 365 days per year, to 5 minutes of a peak period. Like I said previously, flow differs greatly depending on the time of the day and what week it is and what month it is. Hence, adjustment must be made according to the standard adjustment values. There are different methods of measuring traffic flow. One of them is volume counts. It's the most basic data where we collect the number of vehicles in a given time period which passes through a section of a road. Data from traffic volume count helps create traffic map identifying the volume of traffic on major roadways. Then we have directional counts. Directional counts are counts taken of traffic or a roadway by direction of travel. We have lane counts. Lane counts are directional traffic counts taken for each travel lane on a multi-lane roadway. We might have more volume on the right lane compared to the left, as it is a passing lane. Then we have pedestrian counts. Pedestrian counts are counts of the number of people walking through the area. The data can be used to see if a segment of a roadway needs pedestrian signals or not. Now moving on to queuing. Why does queuing occur? Basically, queuing occurs when demand exceeds capacity. We can measure queuing, but we have to take randomness into consideration, which makes it difficult to predict. One more reason why queuing occurs is due to sudden change in number of lanes or bottleneck lanes, a vehicle crash further up a road, which can cause backups, which could be as long as a mile, road closures, a closure of a different route which people used to take makes them take a different route, which increases volume on that route, increasing flow, and hence higher chance of queuing. And shock waves. Here is a quick video of how shock waves might occur. The red cars are changing their lanes, which causes the car behind them to slow down, which causes the car behind them to do the same, which triggers a shock wave that could go back for miles. Now, a good way to prevent queuing is doing the zipper merge. More and more states are advocating for zipper merge, which basically is changing the lanes at the last moment, which might sound a little intimidating, but in theory it should work and reduce queuing because it gives everybody a chance. Now, the study of traffic flow and queuing can help make the experience of the drivers smoother and safer. With basic understanding of traffic flow theory and queuing, we shall talk about highway capacity and level of service in the next video. Thank you.